Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Packing Problem by Clover. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box in this case. In each cage, there is one digit that equals the sum of the other 3 digits in that cage. And digits may repeat in cages if allowed by Sudoku rules. So, as an example, you could have something like, say, 9, 1, 2, and 6, because the sum of the 3 digits, the 3 smallest digits, is equal to the largest digit in that cage. And you can have repeats. So you could have something like, there's only one place where you can actually have repeats, interestingly enough. Anyways, that should give you some information there. But yeah, 9126 is an example of a cage that works because the sum of the 3 other digits, or the 3 smallest digits in the cage, equals the other digit which is in the cage. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So in each cage, there's only one digit that can be from 7 through 9, except for possibly this cage. And there has, 6 through 9. Huh. Right, because there's 4 cells in every cage. And in every cage except this one, there are not allowed any repeats. Because these are all in the same row, same box, same box, same box, same box, same column, same box, same rows, same box, same box, same row, same box. So there are no repeats except possibly in this cage. Okay. Interesting. Unless... So certain cages are completely within a certain amount of cages. So we have 3 cages all within these 2 boxes. We have 3 cages here, which are within these 2 boxes. We have 3 cages here, which are within these 2 boxes. We have so these 3 are within those 2 cages. These 3 are within those 2 cages. So are those 3. And these 3 are within those 2 cages. We only have 2 ones available for each of those 3 sets of cages. That means there has to be one set that's 2, 3, 4 in one of those cages, because you don't have a 1 available for that. So that means there's a guaranteed 9 in one of them. We don't have any other information, though, about the rest. How many digits? So we're guaranteed 3 of these digits. Hmm. Huh. We have 6 cells here in this cage. 6 cells in this cage. That's interesting. Does that tell us much? I don't know. 6 cells in this cage, 6 cells in this cage. 7 cells here, and 5 cells here. So this cannot be. So you can divide them sort of into the high digits and the rest of the digits, which are considered low digits, right? You cannot have 6 low digits here because they add up to, at minimum, 1, 2, 3, 4, 5, 6, which is adding up to 21 at least. So then these two cages would have to have sums of 2 digits adding up to 21, which is not going to work. So this has to be a low end digit. This must have a high, and one of these must be high. So the sum of these two cages must be at least 15, obviously. No, 16. It has to be at least 16 because this is a low. So this is at least 1, 2 lows here, 3, 4, 5. That's 15. So 15 plus 1 or 2 adds up to 17, 16 or 17. So the 9 has to be one of these digits. So we know 9 has to be one of these, and then we could have an 8 or a 7 here. We don't know which. This is definitely a 1 or 2. So this cannot be 1, 2, 6. This has to be at most 1 through 5 here for the lows. And it has to have 2 digits from 1 through 4. Sorry, 2 digits from 1 through 3. So 3 is guaranteed here. The other 1 or 2 is guaranteed here because, again, to have 3 digits adding up to another single digit, it has to be 6, 7, 8, and 9. Well, you're guaranteed 1, 2, 3, 2, 3, 4. Sorry, 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 2, 6, 1, 3, 4, 1, 3, 5, or 2, 3, 4, which means you have guaranteed 2 digits from 1, 2, and 3 here. That means the rest of the box has to be 4 through 9. This cannot be 1, 2, 4, and it cannot be 1, 2, 3. So this is at least 8 or 9 with it. So there's a guaranteed 8 or 9 here. We're not sure which. This must contain 1 through 5, or can you have a 6? You could have a 6 as a low, but that doesn't really tell us much. It's either 1, 2, 3, 4, 5, 7, 9. 1, 2, 3, 4, 5, 8, 9, or 1, 2, 3, 4, 6, 8, 9 here. Okay. So every other set of 3 cages within 2 boxes has 6 applied in each cell. So that's not as restrictive. We know this is definitely a low, and it's 1 or 2. We have 1, 2, 3, 4 here, so this is 5, 6, 7, 8 here, and 5, 6, 7, 8. Because 1, 2, 3, 4 is guaranteed to be in the low digits here, and it's either with 5 or 6. Mm. Um, how many cages in total do we have? So this is 3 cages each. Um, three, 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 and then 2. So 14 cages within 9. 14 cages. Hmm. You could have a 1 here. Then this does not necessarily have to be 9, right? It could be 2, 2, and 4, 2, 2, 3, 2, 2, yeah, 2, 3, 3 as possibilities. Oh, but each set. Okay. So we have 14, right? 14 cages. In certain sets of 2 boxes, we have 3. And we have 2 extras from there. So those 8 boxes, we have 3 in 2 of those boxes each. So 8 divided by 2 is 4. 4 times 3 is 12. 12 plus 2 more boxes is 14. We are guaranteed in each of the boxes, in each of the cages that have in each of the cages that have to be all within the same cage or all in the same row or all the same column. That's 13. We have to have 2 digits at least from each of 1, 2, or from 1, 2, or 3. That means there's 13 cages which must have at least 2 digits from 1, 2, and 3. That means there's 26 cages which have digits from 1, 2, or 3. Sorry, they're in the cages there have to be 26 digits from 1, 2, and 3. And there's 27 total, right? There's 3 digits from 1, 2, and 3, and then all times 9. That's 27. So there can only be one other digit from 1, 2, or 3 in this leftover box. And because of that, it has to be 1, 4, 4, and 9. Oh, that's fascinating. Right, because there cannot be a 1, 2, or there has to be, again, if you try to have 2, 1, 2, or 3s in this cage, the problem is this has 2 digits from 1, 2, or 3, so that's 2. So does this, so does this, so does this. So that's one, for each cage, you have 2 digits from 1, 2, or 3 in this cage to add up to 6, 7, 8, or 9. So none of them can add up to 6. You could potentially add up to 7, but um that means there's only one left over from 1 through 3 for this cage. And it has to have 1. Because if you don't have a digit from 1 through 3, the minimum is 4, 4, and 5, which adds up to 13, which is not a single digit. So you have to have 1. You can't have another digit because you already have 2 digits from that cannot be from 1 through 3, right? Because you already have 26 of them and you have 27 total. So therefore you have to have 1 and it has to be with 4 and 4. So this must be 1, 4, 4, and 9. So this is 1, 4, 4, and 9. That means this is 4, 4, or this is 4 and 4. Either way, one of these two is 4. So there's got to be a 4 here and a 4 here, which eliminates 4 in the rest of the column and row. So this cannot be 4 here. This can't be 4 here, which means this must be a 4 here. That's interesting. So this is guaranteed to be 1, 4, 4, and 9. But we don't know which one's which. 1 cannot be here, because if this is 1, this becomes 2, 3, 4, and 9. That eliminates all possibilities for this box. Or this cell specifically. So 4 has to be here. So this is either 1, 2, 4, 1, 3, 4, or 2, 3, 4 with 9. So this could be 7, 8, or 9 here. That means this cannot be 4. It cannot be 1, 2, 4. If this is 1, 2, 4, this has to be 3 and 5 at least. Well, I guess that could work. No, that actually could work. Because it could be 3, 5, and then this is 9. We know in the rest of the cages there are no 1, 2, or 3s. Because we have them all accounted for in the cages. So the rest of the cages are 4 through 9. Sorry, rest of the non-cages are 4 through 9. And this cannot be 4 because one of these is guaranteed 4. These can't be 4 because one of these two are guaranteed to... 2 out of 4 of these are guaranteed to be 4. No 4 here, no 4 here, no 4 here. Okay. What's the sum of them? I need to go bathroom. I'll be right back. Okay, and I'm back. Let's continue. Okay. This is interesting. If this is a 4-9 pair, that means one has to be there. Which means this must be a 1, 2, 3 triplet there. That's possible. Oh. In column 8... do we have all rows or all columns which are part of a cage? I don't think so, right? Well, this could be 1, 2, 3, and this is 6, maybe. No. No cage can have more than 2 digits from 1, 2, and 3. So, This is 2 out of the 3. This must be 1. So this is 1, 2, or 3 here. This is 2. So this must be 1 also. This is 2. That means these are both highs. So this is guaranteed 2. This is at least 1. Oh, wait, that's not true. Because this doesn't have to be the 1, 2, or 3. It has to have one of the lows. But the lows could be 4, 5, or 6, right? Right. Okay, so we have anywhere there's 5 in a column with 4 of them being the same set. So this is 3. Sorry, 2 out of 3, and it's one of these two then is a guaranteed low, or a low. I guess we could say low, middle, and high, right? The high, yeah, because nothing could be 1, 2 plus 3, because nothing requires that, right? We have 5 here, but that doesn't tell us much. This is 8 here. Interesting. This is 8 here also. We have 1, 2, 3, 4, 5 here. But it could be 1 and 4. Or 4 and 9. This is at least 2. So we know there's a mid one here. That means the other two are lows here. That means there's one low and one mid here. Okay. Can this ever be 1, 4? Okay, so 9 can never be here. If this is not... No, 9 could be here if this is 1. Never mind. But if this is 1 and this is a 4, this has to be 2, 3, and 5, adding up to 10, which is not allowed. So this can never be 1. Therefore, this is a 4-9 pair, which eliminates 4 and 9 in the rest of the column. So this cannot be 9 here. This can't be 9. This is guaranteed to be 1. So this can never add up to 9, and it doesn't have a 4. So this has to be 1, 2, 5 here. This adds up to 9, and it has to be with a 4. That's only then requires 2 and 3. So this has to be 2, 3, 4, and 9. That eliminates 2 here. So that means this must be... It cannot be 1, 3, 4, cannot be 1, 2, 4, cannot be 1, 2, 3. So it has to be 1, 2, 5, adding up to 8. So this is 8, and it cannot have 2. So this is 1, 5, 8, which forces this to be a 2. That means this cannot be 5 or 8. This can't be 5 or 8. This can't be 1, 2, 5, or 8. This can't be 5 or 8. Oops. This can't be 5 or 8. This becomes a 6, 7 pair. That forces this to be 3. This cannot be 2 or 3. If it's 1, 3, 5, this is 9. If it's 1, 3, 4, this is 8. So this is guaranteed to be 4 or 9 here, which means this cannot be 9 here, and it cannot be 9 here, and this can't be 4. This is guaranteed to have a 1 in it. So this is 2, this is 1, 5, 8, 2, 3, 4, 9. So this is a low. One of these is medium and one of these is high. That means this cannot be 9 here. So this has to be a 1, 4 pair here. This is 1, 5, 8, adding up to 1, 2, 5, add up to 8. We have a 6, 7 pair, 6, 7 there. This must be 1, 2, 3, 4, 5, 8, or 9. So we have guaranteed 8 in one of these. We don't know which one. This cannot be 4 because we have already guaranteed 4s in columns 3 and 4. Again, this is 1, 3, 4 adding up to 8, or 1, 3, 5 adding up to 9. So every cage must have 2 lows, which are the digits from 1 through 3, except for this one. This has 1 low and 2 highs. Okay, actually, we should know something here. This is 2 digits, which are from 1 through 3. This is 1, 2, so that's 5. We have 3 here, and this is 1 digit from 1 through 3 there. Okay. That doesn't tell us too much. If this is 1, this has to be 2, 3, 4 here to add up to 9. So none of these can be, otherwise this is 4, which forces this not to be 4. So either way, this can never have a 4 here. So if this is 1, this is 2, 3, 4, and 9. 4 cannot be any of these. So what are the remaining digits in row 3? We have 2, 3, 5, 6, 7, 8, 9. This can't be 3 because of the 3 in the column. Okay. If this is 1, this has to be 2, 3, 4. and 9. So this can never be 4 here. So we are guaranteed in row 1, right? If this is 1, this is 2, 3, 4, 9. If this is 1, this is 2, 3, 4, 9. Otherwise, if this is 4, obviously 4 can't be in the rest of this box. So we know 4 has to be one of these two, which eliminates 4 in the rest of this box here, because there's no other place for it, right? If this is 1, this becomes 2, 3, 4. Otherwise, there's 4 here, which eliminates 4 from the rest of the box. If this is 1, this is 2, 3, 4. Otherwise, this is 4, which eliminates 4 from the rest of the box. So 4 has to be here. So this must be 4 with 1 and 2, 1 and 3, or it's 7, 8, or 9. This can't be 3. This can't be 2 here. That doesn't work. Okay, so if this were a 1, this would be 2, 3, 4, but then this would not have any possibilities. Because the reason is this has to have, if this is 1, this becomes 2, 3, 4, this has to be 2 high digits, because 4 only adds up with 1, 2, 1, 3 to add up to, or 2, 3 to add up to 7, 8, or 9. And this is guaranteed to be a 4. So this must have a digit from 1 through 3. This must be 2 digits from 1 through 3, which means this cannot be a digit from 2 to 3. Therefore, it's 4, which forces this to be 9, which makes that 4, which makes that 1. So this is a high digit. This is a medium. This is medium. That eliminates 4 from the rest of this box. That means this has to be 2, 3, 4, and 9. And it cannot be 4 here. So the 9 cannot be in the rest of the box. This obviously can't be 4. This can't be 1. We have a 4 guaranteed here. Not sure about this. So 4 cannot be here, cannot be here, so it has to be here. So this is 4, which makes this a medium. This has 1 low. This has 2 lows here. Right, there has to be a low here because of that. This is 9, so this cannot be 9. This must be 1, 4, and 8. So have 1, 3, 4 adding up to 8. 4 cannot be here. 4 has to be one of these 3 cells. 4 is one of these. It could be 1, 2, and 4 with 7. 1, 2, 1, 3, and 4 with 7. Okay. So this can never add up to 7 here. It can never have 6 and 7. 6 and 7 can never be, 7 could be in cages. 6 can never be in cages. So this can never be 6. Which means 6 has to be one of those two. We have a 5, 6, 7 triplet in row 6, which eliminates 5, 6, and 7 in the rest of the row. This cannot be 5. One of these has to be a 5. That eliminates 5 here. So we have a 6, 7, 6, 7 pair in row 5 too, but that doesn't eliminate anything because we've already eliminated most of 6 and 7. Okay, this 9 eliminates 9 in the rest of the column. That means we have just 1, 2, and 3 left in the rest of column 4. So those are both low. These are low. This is low. That means we have a 5, 6, 7, 8 quadruplet in row 1 because this can't be 9 anymore either. That eliminates 5, 6, 7, 8 in the rest of the row, so this has to be 9, which means this must be 2, 3, 4, and 9. You can only have one of the 2 or 3s here, so this cannot be 9 here. This is 2 or 3. This is 9. That forces this to be a 1. So 9's guaranteed here, which eliminates 9 in the rest of the row, or box. So this is guaranteed to be 9. That means this cannot be 9 here, because again, the 5, 6, 7, 8 quadruplet eliminated 5, 6, 7, 8 as possibilities here. That means this cage must add up to 9. So this is 1. It could be 2, 5. It cannot be 1, 3, 5 here. If this is 1, 3, 5, that adds up to 9, but we have a guaranteed 9 here. So it has to be 1, 2, 5 here, which makes this 9 and 3, so this cannot be 3 here. This is a 2, 4 pair. This then must add up to 1, 3, 5, adding up to 9. So this is 1, 3, 5, and 9. That eliminates 5 and 9 in the rest of the box. We have 2, 3, 5, 9 quadruplet in row 3, which eliminates 2, 3, 5, and 9 in the rest of the row. This cannot be 2 or 5, so this must be 8. This has to be a 6, 7 pair here. That means 8 has to be one of these 2 digits, so this cannot be 8 here. This is 1, 2, and 5, and this can't be 2. So we have 2 lows here and 1 mid. That eliminates 5 and 8 in the rest of the box. So this can't be 5 either. This can't be 5 because of the 1, 2, 5 triplet. That eliminates 2 here. So this is 3 or 9, this is 3 or 9, and this is 2. This one eliminates 1 in the rest of the column. So this is 3 guaranteed here. This can't be 8 because of the 8 in the column, so we have a 1, 4 pair here, which eliminates 1 and 4 in the rest of the column and the rest of the box. This can't be 1 or 4. This is 8, which eliminates 8 in the rest of the row. This can't be 1 because of the 1, 4 pair in the column. This can't be 4, 8, or 9. So the remaining digits in, well, 6 can never be in any of these cages because 6 is the sum of 1, 2, and 3. But we've shown every cage must have 2 and only 2 digits from 1, 2, and 3, except for this one, which has 1. So where is the 6 in column 5? It has to be here. That means this can't be 6. There's also a couple more with 8. I think at least one more that had 8 in the row or column. I know this was one. So this is 2, 5, or 7 here. So one of these is a 7, which eliminates 7 in the rest of the box. Interesting. So the 7 cannot be the one with the 3. Huh. So that means 6 cannot be here. Where is the 6 in row 8? It has to be one of these 2 cells. Can't be here. Yeah, this is 8 cells. So this has to be a 6 here, which eliminates 6 in the rest of the box. That means one of these 2 is a 6. So I think that might have been the other one that had 8 cells all in cages. Row 1, nope. Row 2, nope. Row 3, nope. Row 4, we have a 6, 7 pair there. Row 5, 6, 7 pair. 6, nope. 7, nope. 8. This can't be a 4 because it has to be one of the low digits. So this is 1, 2, or 3. We have 8 there. 8 in column 5, not in row 9, not column 1, not column 2. Okay, this can't be 6 because of the 6 in the column. 1, 2, 3, 4, 5, 6. in column 3. 1, 2, 3, 4, 5. In column 4, we have the column 5 already. Column 6 only has 6. 7 doesn't have a guaranteed 6. Oh, we have a 6, 7, 6, 7 pair in column 7, which eliminates 6 and 7 in the rest of the column, so this can't be 6 or 7. This is 8, which eliminates 8 here. This eliminates 8 in the rest of the column. It also eliminates 6, 7, and 8 in the rest of, the rest of the column. So it's 1, 2, 3, 4, 5, and 9. Okay, this can't be 8 because of the 8 in column 6. So where's the 8 left? We have a 6, 7 pair in column 4, which eliminates 6 and 7 in the rest of the column. So this is 5, which means this can't be 5. This 5 eliminates 5 here, so this is 8. We have a guaranteed 7 here, and it must be from with 1, 2, and 4. This 8 eliminates 8 here. 6 is one of those two, one of those two, one of those two. 5 has to be one of those two cells. This is a low. We have a high here, high here. One of these is high. So either this is 7, which makes this 1, 2, 4, or this is 7, which makes this 1, 2, 4. Let's see, what else do we have? This must, okay. This either adds up to 8 or 9 here. So this has to be either 1, 2, 5 or 1, 3, 5 to add up to 8 or 9. So either way, 1 and 5 are here, which means this cannot be 1 or 5. It has to be 8 with 2 or 3. So if this is 1, 3, 5, 9, this is 2 and 8, which forces it to be 1 and 5. If this is 1, 2, 5, 8, this is 9 with 3, but it could be with 2 and 4. So this is either 1 and 5 or 2 and 4, and it cannot be 3, right? So again, here, this is either 1. Okay, we know 1 is guaranteed here. You have, this is either 1, 3, 5, and 9. That forces this to be 2 and 8. So this would be 2 here, 8 here. Which would have to be 1 and 5 here to add up to 8. Because it can't be, 8 minus 2 is 6. The only pair of digits that add up to 6 now without a 2 is 1 and 5. Otherwise, this could be, this is 1, 2, 5 with 8. So this would be 3 and 9. So it's either 1, 5 or 2, 4. So this can never be 3 here. So this is 1, 2, and 4, 5. This could be 3 or 9 here. This can never be 7 then, because if this is 7, that would force this to be 1, 2, 4 to add up to 7, but that would eliminate all possibilities for that cell. So this can't be 7. Therefore, this is 7. Therefore, this must be 1, 2, and 4, adding up to 7. So this is 1, 2, 4, which eliminates 1, 2, 4 in the rest of the column. So this must be 5, which makes this a 4. That eliminates 5 in the rest of the box and the rest of the column. This is 6, 7 pair, eliminates 6 and 7 in the rest of the column. So this must be 8. That can't be 8 here. So this must be 8 here, which makes this a 1, 2, 5. And 8 here. 8 cannot be here. 5 cannot be here. 1 can't be here. That eliminates 2 here. This is a 3, 9 pair. That must be with 1. This 3, 9 pair eliminates 3 and 9 here. So that's 2, which means this can't be 2. So this is a medium. This is low and high. This is low. These can't be 8 because of the 8 in the box. The remaining digits in row 8 are 3, 8, and 9. Okay, and this cannot be 8. If this is 8, this would have to be 1, 3, and 4, but we already have a 1 in the box. So this can't be 8. It must be 2, 3, and 9 here. And this can't be 2 because of the 1, 2, 4 triplet in the row. So 8 has to be here, which means this can't be 9. This is 3, 8, which means the remaining digits are 1 and 4 to add up to 8. So this makes this a 9, which means 9 cannot be here. This is a 2, 3 pair. This 9 eliminates 9 in the rest of the box and the rest of the column. So this is 3, this is 9. This 3 eliminates 3 here, so it's 2 and 3. 2 eliminates 2 here. So this is a high. These are the lows. This is the medium. Medium. Which means this can't be 4. This is a 3, 8 pair. It has to be with 1 and 4. That doesn't work. That's problematic. My logic must have been wrong there. I think this logic is all sound. I don't know about this part, though. Three definitely has to be one of these, and this can't be 8 because 8, 4, 4, and 2 doesn't work. This has to be 9. 2, 3. I think that's problematic, though. 3, this can't be 9. 3, it's 1, 3, 4, and 8, and that's problematic because of the 4 in the row. Oh, I see where I think I messed up. Right. No, this has to be low. This has to be low because we have 3 lows. We have 2 lows here. This has to be the third one. That has to be a low. Shoot. I was going to say this could be a 4, but that can't be. This cannot have a 1, so it has to be 2, 3, 4, and 9. So that's 2, this is 3, this is 1. That makes us 4. And this has to be 9 and 4. So no 4 and 9. No 7, 8. It's a 5, 6 pair. That means this is 2. But how do you have 3 and 8 adding up with 1? You can't, right? No 4, 5, or 7, so it's 9. So it'd have to be 1 and 7 here. Not good. Not good. This can't be 3 or 9. This is 3, 9, 5, 9. And that this 2, 4 pair eliminates 2 and 4 here. So that's problematic. Okay. Where did I mess up? I think the logic mix is very sound. Ugh. Okay, let's restart with keeping track of where the 6s have to be. Maybe that's helpful. In row 8, this has to be 6. In column 5, this is a 6. I think this is still solid, though, right? Again, we have 14 cages, 13 of which are guaranteed to have 2 digits from 1 through 3. Therefore, this must be 1449. 6 has to be one of these two. 6 has to be one of those two. Why can't this be 1 again? Well, this can't be 1, oh, because of the 7 here, right? So this has to be a low. This has to be low. This has to be low. 1, 2, or 3. And this is guaranteed to not be 1. We tried to have a 1 here, but that forces this to be 2, 3, 4, 9. That eliminates all possibilities for this cage. So this is 4, 9. This cannot be 9. It cannot be 1, 2, 3, and 7. It has to be 1, 2, 3, and 8 here. Sorry, 1, 2, 5, and 8. Because it cannot be 1, 3, 5, 9. Can't add up to 9. Can't add up to 6. Can't add up to 7. Because that would require 1, 2, and 4. So one of these is 9, which means this cannot be 9 here, right? 1, 4, and 4 add up to 9. So this has to be 1, 2, 5, and 8. And this can't be 5 or 8. That means, again, you need 1, 2, 3. This is 5. And you have 8 here. So this must be 2 here, because this is 1, 2, 3, 4. It has to add up to 8 and 9 here. So this is not 2. This is 2, 3, 4, and 9. This becomes a 6, 7 pair. This does not have 2. It cannot be 1, 3, 5. Oh, it could be 1, 3, 4, and 8. Or 1, 3, 5, and 9. Therefore, this is 5, 6, 7, 8, because the 4, the 9 are guaranteed here. This can't be 4, 9, 1, 5, 8. It's 3. That leaves us as a 6, 7 pair. So this is all still kosher. This can't be 3. Again, if we had, this is guaranteed 2, so this has to have 2 out of digits 1, 2, 3. This can only have 1, so the other one has to be here, which means this is 2 out of 1, 2, or 3. Therefore, that forces this to be 4, which makes that 1. This 4 eliminates 4 here, so it's 9 and 4. This is a high. That means this cannot be 1, 3, 5 adding up to 9. It's 1, 3, 4 adding up to 8, which eliminates 8 from the rest of the box. This is 4 and 9. The remaining digits of 1, 2, 3 have to be in the cages in column 4. So this must be 5, 6, 7, 8. 5, 6, 7, 8. These are 1, 2, 3. 1, 2, 3. This has to be 2, 3, 4 adding up to 9. So 4 cannot be here. 4 cannot be here. This must be a 4. Which means 4 has to be one of those two. This must be 5, 6, 7, 8. This 5, 6, 7, 8 triplet eliminates 5, 6, 7, 8 in the rest of this row. So this must have a 9. So it must be, and we know 4 cannot be here or here. So 4 has to be here, which means this is 2, 3, 4, adding up to 9. And this is the low. This can't be 2. This can't be 4. This can't be 3. This is guaranteed to be 9. You can't have 1, 2, 3 adding up to 6. You can't have 1, 2, 4 adding up to 7. You can't have 1, 3, 4 adding up to 8. You can't have a 9 here. So this was 1, 2, 5 adding up to 8. This can't be 1 because of the 1 in the row. This is 1, 2, 5, 8, which eliminates 2 here, so that's 9, which makes this 3. That eliminates 3 here. This is a 2, 4 pair. To add, this has to be 1, 3, and 5, adding up to 9, because that's the minimum here. So this is 3, 5, 9. That eliminates 3, 5, and 9 in the rest of the box. So this is 6, 7, 8. That's fine. This can't be 2 because of the 2 in the column. We still have to have a 7 here. So one of these is a 7, which eliminates 7 in the rest of the box. This is a 5, 6, 7 triplet here, which eliminates 5, 6, and 7 in the rest of the row. So this is 1, 2, 3, 4, 8, 9, no 4. 3 is one of those two. Maybe it was here that I messed up. I don't know. No, we have a 2, 3, 5, 9 quadruplet here, which eliminates 2, 3, 5, 9 in the rest of the row. So this has to be 8. This has to be 5. This can't be 8 anymore. This is a 6, 7 pair. Yeah, we run into the same problems. This is a 5 guarantee. This cannot be 5. This can't be 1. 6, 7, 6, 7 pair, which eliminates 6 and 7 in the rest of the column. So this is 8. This can't be 8 here. That means this can't be 8. We have 1, 2, 3, 4, 5, and 9. This can't be 1. This can't be 8 or 5. So we have a 6, 7 pair. 5, 6, 7. This forces this to be 8, which means this can't be 8 here. This is guaranteed to be 1 and 5 with 2 or 3. So this cannot be 1 or 5. Which means 5 has to be one of these two. So this cannot be 5 here. This is guaranteed to be 1. 1 has to be one of those 3. This is guaranteed to be 5 here. So 1, 5, and 2 add up to 8. 1, 3, 5 add up to 9. These can't be 8, so that forces this to be 8. This can't be 1. We have a 2, 5, 7 triplet here again. If this is 3, that means this is 1, 3, 5, and 9, so that would be 2 and 8. That just doesn't work. And I run into the same problem again. So this can't be 3. This can't be 1, 2, 4, because that would eliminate all possibilities for that cell. So this has to be 7, which makes this 1, 2, 4. Which means that can't be 1 or 4. So the remaining digits are 3, 5, 6, no 6, 3, 5, 8, 9. 3, 5, 8, and 9. This has 2 lows and a middle. This can't be middle. because we have 4 and 6 here. So this has to be high and low, so this cannot be high or low. Ah, can't be 3, this is 5. 5, 2, and yeah, it's just this has to be 4. That eliminates 4 here. It fails, right? I mean, this can't be 8 and 9. So 3 is guaranteed here. This is not 3. I don't know. Okay. 3 has to be one of these two, which eliminates 3 in the box. That means where's 3 in column 7? It has to be here. That eliminates 3 here. Where is 3 in row 6? It must be there. I have a 6, 7, 6, 7 pair in column 4. So this must be 5, which means this can't be 5. We have a 6, 7, 6, 7 pair in column. This can't be 7. Remaining digits in column 6. We have 1. This can't be 2. 1, 4, 5, and 9. This must add up to 9. It could be 2, 3, 4. So this is 2 or 5, which eliminates 2 and 5 in the rest of the row. Because it's either 1, 2, 3, 4 or 1, 3, 5, adding up to 9. So this is 3. And we run into the same problem. So this cannot be 2 or 5. This is 2 or the only 2 or 5 here, so this can't be 2. That's 1, which makes this 2, 4, 9. That makes this 5. This is 1. This is 2. This is 1. So that makes this 4. This has to be 9 then. That's 5, which makes this 4. And this is 2, but then that eliminates all possibilities for this cell. And I'm running into the same problem. I don't know where I'm making the mistake. All the other ones seems logical, right? Maybe it's somewhere in the beginning? Where I'm certain this has to be the case. This is 1, 4, 4, and 9. Because there's 7 here, this has to be a low. Could this be 1? No. This can't be 4 or 9. I mean, so this has to be, this is 1, 4, or 9 guaranteed. But because of the way this works, we know this can only have 2 out of the digits from 1, 2, or 3 here. But this is already guaranteed 2 digits from 1, 2, or 3. So this must be from 1, 2, or 3. This has to have 2 digits from 1, 2, or 3, so this cannot be 1. And if we try to have this as 1, this would guarantee this is 2, 3, 4, 9, which eliminates all possibilities for that cell. So this is not 9. This is a 4, 9 pair, which forces this to be a 1, 4 pair. Without 4, you can't add up to 9. It could technically be 1, 2, 3, but we know every cage can only have exactly 2 digits from 1, 2, and 3. So that means it's 1, 2, 5 or 1, 3, 5, but 1, 3, 5 adds up to 9 and it's not possible. So this is 1, 2, 5, and 8. This is low. Six is one of those. 6 is guaranteed to be here. 6 is guaranteed to be there. That guarantees 6 here. 6 is here. This is 3, 6, or 7. If it's 7, it would have to be 1, 2, 4 here, which is not allowed. So this is 3, which forces this to be a 6, 7 pair. So 3 plus 2, 3. Well, no, this is guaranteed to be 8. There has to be a 9 here. Because otherwise, we're guaranteed a 9 here. Because these cages must add up to what these maximum digits are. And because this is either adding up to 16 or 17, which means a 9 is guaranteed here. We know 8's here, so 9 has to be guaranteed here. So this must be 2 with 1, 2. I guess it. No, because 4 has to be here. Because 4 has to be in this cage to add up to at most 15 or 16. So this is guaranteed to have a 4, and it must add up to 9. That means the other 2 digits must add up to 5 without a 4. So this is 2, 3, 4, and 9, which eliminates 2. So this is 1, 5, 8, which forces this to be 2. Yeah, so this is still the same. That leaves a 6, 7 pair in box 6. We are guaranteed a 1 here. It's 1, 4, or 8, or 1, 5, and 9. Again, this requires 2 digits from 1 through 3. This requires 2 digits from 1 through 3. That means there's 1 digit here from 1 through 3 and 1 digit here from 1 through 3, which eliminates 1 here. So this must be 4, which makes this 9, which makes that 4, which makes that 1. This is low. This is medium. This is high. This cannot add up to 9, so that no 1, 3, 5. It's 1, 4, 3, 4, adding up to 8. That leaves 5, 6, and 7 remaining in the box. One of these must be 5. This can't be 5. We have a 6, 7 pair here. It just keeps running into the same issue, right? This is 2, 3, 4, 9. 4 cannot be here or here, so this must be 4. We have 5, 6, 7, 8. This can't be 6 because of the 6 in the column. This cannot be 9. It's 5, 6, 7, 8. Can't be 4. We have 5, 6, 7, 8. We have to have a 4 here. This is low. This is I don't want to do this as low, but I don't know what else I can do. This has to be 2, 3, 4, 9. 4 can't be here. This can't be 2. This can't be 3. one of the 2 or 3s here, so this is 2, 3, 4. This must be 1. 1 has to be one of these. It's either 1. It cannot be 1, 3, 5 because that would force us to be 9. 9 here, which would eliminate all 9s. We keep running into the same problem, right? This is 1, 2, 5, 8, so that makes this 9, which makes that 3. That eliminates 3 here. This is minimum 1, 3, 5, adding up to 9. So we have the same issue again. The 2, 3, 5, 9 quadruplet, which eliminates 2 and 5, so that's 8. Can't be 8, 6, 7. This can't be 8 here. No 8. No 5, 6, 7. This is 5 and 8. So this can't be 5 or 8. It's still the same problem, right? This can't be 2. I don't know. This can't be 8. This is 8 there. This can't be 6 or 7. I just don't, yeah, I don't know. This has to be low because of the lows cannot be, have to be in cages in each column. Because we have all the cages, all the 1 through 3s accounted for in cages. This can't be 6 or 7, it's 5, which means it can't be 5. This is 8. This can't be 1. We are guaranteed a 7 here. That's the problem. 6, 7, 6, 7 pair, which eliminates 6 and 7 there. That's 8, which means this can't be 8 here. I don't, yeah, I don't know. This can't be 2. We have what? 1, 4, 5, and 9 left. Two lows here. But you can't have 1, 2, 6, right? Oh! That's one problem. The 6 is a bad assumption. You could have 1, 2, 6 adding up to 9. Okay, that's the bad assumption we were having. So 6s are not necessarily outside. Okay. That's the issue we have. Okay. So everything else still makes sense, right? This has to be 1, 4, and 9. So this is all still the same. Because of the way this works, again, this can't be 1. If we try to have a 1 here, that would force us to be 2, 3, 4, and 9, which would eliminate all possibilities. So this is a 4, 9 pair. This is 1, 4. The 6s was getting me off. Okay, so that was what was screwing me up. This cannot be 4. You can't have a guaranteed 6 there. 1, 2, 3 doesn't work because you can't have more than 2 3s. 2 digits from 1, 2, 3 in the same cage. So this does have to be, cannot be 1, 2, 4, cannot be 1, 2, 3, can't add up to 9. So it has to be 1, 2, 5, and 8. So this is guaranteed. This is then 3, 6, 7. It could be any of these are 3, 6, 7. Okay. This is guaranteed to be 8 here because this we have to have only 2 digits from we have to have 2 digits from 1 through 3 here. 1 digit has to be here, then 1 has to be here. So this is low. Same this is also low, and this is low. So those are correct. The 6s was the bad assumption. Okay. So this must be 8. This must add up to 9 because you have the digits 1 through 5 or 1, 2, 3, 4, 6 adding up to 16 or 15 here at minimum. So this total adds up to 16 or 17. That means 9 has to be here. 4 has to be here too. So this must be 2, 3, 4, 9, which eliminates 2, 3, 4, and 9 in the rest of the box. So this is 1, 5, 8. This must become 2. This, though, cannot be 6. Okay, that's the bad assumption we had. Okay, so this is not necessarily 6. Okay. That's the key. So, but if this were 6, it cannot be 1, 2, 6 adding up to 9 because we have a 2 in the box. It can't be 1, 2, 3 adding up to 6 because we have a 2 in the box. So 6 can't is right out. 7 is out for the same reasoning. You have to have 1, 2, 4 adding up to 7. So this is still 3, which eliminates 3 here. Therefore, to add up, this is low again. We have the same issue. So this is all still the same. This is 4, 4, 9. This is 1. Therefore, this is 1, 3, and 4 adding up to 8. This is 2, 3, 4 adding up to 9. This has to be, we have 5, 6, 7, 8 here. This can't be 4, this can't be 4, so this must be 4 there. We have to have a 4 here. And again, this can't be 4 or 9, so this is 5, 6, 7, 8, which means this is 2, 3, 4 adding up to 9. So this is all still the same, 2, 3, and 4. This is 2, 3, and 9. This can't be 2, this can't be 3. You don't have a 4 available. You can't add up to 9 because one of these is 9 guaranteed. This has to be a 1. And this must be, cannot be 1, 2, 4, no 1, 2, 3, no 1, 3, 4, and it can't add up to 9, so it's 1, 2, 5, and 8. Which means this can't be 2, this is 9, this is 3, this can't be 3, this becomes a 2, 4 pair, which means this is at minimum 1, 3, 5, and 9. Which is exactly what it has to be. Therefore, this is 6, 7, 8. We have a 2, 3, 5, 9 quadruplet in row 3, which eliminates 1, 2, 5, and 2, 3, 5, and 9 in the rest of the row. So this has to be 8. This can't be 8. It becomes a 6, 7 pair. No 8 here. This can't be 5 or 8. It's 6 or 7 here. This 8 eliminates 8 here, so this has to be 8 here. This cannot be 1. This has to be 5, 6, or 7. 5, 6, or 7. Again, the 1, 2, and 3s are only in cages, so these are 1, 2, and 3. This cannot be 5. We have a 5, 6, 7 triplet, which eliminates 5, 6, and 7 in the rest of the column. So this must be 8. We have a 5, 6, 7 triplet here, too, which eliminates 5, 6, and 7. So this is the only one that satisfies both. So this is 5, which means this can't be 5. This can't be 5. The rest of column 5 is either 2, 5, 6, or 7. Interesting. And we've tried this being 6, so obviously this can't be. One of these is 6. So it must be 1, 2, and 6 with not... Okay, so this all is still the same. This is 1, 2, or 3. But to add up to 8 or 9... it must be 1, 2, 5 adding up to 8, or 1, 3, 5 adding up to 9. So 1 and 5 are here. So we're guaranteed 5 has to be one of these two. 1 has to be one of those two. And either this is 1, 2, 5, and this is 3 and 9. So 1, 2, 5, 8. This can't be 1. This can't be 5. This can't be 8 here. Or this is 3 and 9. And then this is 2 and 8. Either way, this can never be 3. If this is 3, that would force this to be 2, 8, and there would be another 3 here. So this is 1 and 2. Okay. So the question is, can this ever be 7? If this is 7, that would force this to be 1, 2, 4 to add up to 7. And that's not possible because it would eliminate all possibilities for that cell. This can't be 5 or 8. We have a 6, 7 pair here, which eliminates 6 and 7 in the rest of the column. So again, this can't be 7, and this can't be 6, because if it's 6, again, it can't have 1, 2, 3 adding up to it, because again, every cage must have 2 digits from 1, 2, and 3 at most. So this cannot be 1, 2, 6 adding up to 9, because that would eliminate all possibilities for this cell. So this can't be 6 or 7, which means this is a 2, 5 pair here, which eliminates 2 and 5 in the rest of the column. So if this is 6, it must be 1 and 2 adding up with that to add up to 9. If it's 7, this is 1, 2, and 4. So this can never be 3 here, which means 3 has to be in this cell here. Okay. This is 1, 2 with 4 or 5 here. So it was this part that was mistaken. So this is 6 or 7. If it's 6, it has to be 1, 2, and 9. If it's 7, it's 1, 2, and 4, adding up to 7. So those are the possibilities. We just showed that 7 cannot be here, because that leads to a contradiction, which we're running into over and over and over again. One of these is a 4. This can't be 2. Remaining digits in column 6 are 1, 4, 5, and 9. Okay. So 3 has to be with 2 or 5 here. If it's 2, it has to be with 9 and 4. If it's 5, it has to be with 1 and 9. So there's a guaranteed 9 here. So this can never be... Okay, so yeah, if this is 3 and 2, this is 4, and this is 1. If this is 3 and 5, it has to be with 1. So this is guaranteed 1, 2, or 5 here. Okay. So if this is 3 and 2, we have 4 and 9 here. If this is 3 and 5, this is 1 and 9 here. Okay. With 9 guaranteed to be one of those two. This 6, 7 pair eliminates 6 and 7 in the rest of the column, so this can't be 6 or 7. This is 8, which means this can't be 8. This can't be 8 either. We are guaranteed this is 1 and 2. 1 and 2 cannot appear in the rest of this row. So it must be... If this is 2 and 4, that guarantees this has to be 3 and 9, because you can't have 2 and 8 here. But we'd have 2, 3, and 9 here, which would eliminate all possibilities for that cell, so this cannot be 2. This is 1, which means this cannot be 1, 3, and 5, adding up to 9. It's 1, 2, 3, and 4 adding up to 9. So this is 2, which makes this 5, which makes that 1, which makes that 2. So this can't be 2, that's 1. That eliminates 1 in the rest of the box. So we have a 4, 9 pair, which eliminates 4 and 9 in the rest of the box. So that's 5. This can't be 1. This is a 4-9 pair here. This can't be 1 because of the 1 in the row. This must be 1 and 5, adding up to 2 and 8, or 3 and 9 here. That eliminates 5 here, so this is 8. That leaves this as a 4. This cannot be 2 and 8 anymore. It becomes a 3-9 pair, which eliminates 3 and 9 in the rest of the column. So that's 2, which eliminates 2 here. This can't be 5. One of those is 5. This must be 1, 2, 3, 1, 2, 5, and 8. This can't be 1, no 5, no 8. This has to be 2, 3, 4, adding up to 9. So this is 2, 3, 9, which leaves this as 6, 7, and 8. Okay. We have a 2, 3, 9 triplet in column 2, which eliminates 2, 3, 9 in the rest of the column. So this can't be 2, this can't be 2. And one of these has to be 2, so this can't be 2 here. We're guaranteed a 2 here. Okay. This is guaranteed to be 1 and 2 here. Either 1, 2, 4 adding up to 7 or 1, 2, 6 adding up to 9. So this cannot be 2 here, which means this has to be a 2 here. Which means this has to be 2 here, because this cannot be, we have to have 1, 2 with here, and it cannot be here. Therefore, this is 2, which eliminates 2 here, so it's 4, which makes that 2. 4 eliminates 4 here, so it's 9, which makes that 4. That means this can't be 4, so this is 9, so this must be 1, 2, 6, adding up to 9, which means this is 7. This 6 eliminates 6 here. This cannot add up to 9. You can't have a 2 here. This must be 1, 3, 4 adding up to 8. 4 cannot be here. 8 cannot be here. This must be a 1, 3 pair, so those are both low. This 2, 4, and 9 eliminate 2, 4, and 9 here, so that's 3. That eliminates 3 in the rest of the box, and that eliminates 3 in the rest of the row, so this is 9 and 3. This 3 eliminates 3 here, so it's 1 and 3. 1 eliminates 1 here, so it's 5, which means this can't be 1 or 5. This must be 8, which makes this a 1. So this can't be 1 or 3. This is 4 and 8, which eliminates 4. This 8 eliminates 8 here, so that's 4 and 8, which eliminates 8 in the rest of the row. This can't be 8. This is 7. This can't be 9 because of a 9 in the row, so that's 3, which makes this 9. This 9 eliminates 9 here, so it's 3 and 9. These can't be 7 anymore. That forces this to be a 5, 7 pair. This can't be 4 because of the 4 in the column. This has to be a 6 because that's the only digit remaining. This 6 removes this 6 here, so it's 7 and 6. These can't be 2 because of the 2 in the column. This 9 eliminates 9 here, so it's 4 and 9, which makes this 2. This can't be 2, so it's 8, which makes this 1, which makes this 5, which makes that 2. This 8 eliminates 8 here, so it's 6 and 8. This can't be 6, 7, or 8, so it's 5. This 7 eliminates 7 here, so it's 6, which makes this 7. This 1 eliminates 1 here, so it's 4, which makes that 1. 7 eliminates 7 here, which makes this 6, which makes that 7. None of these can be 9, so it's a 3, 5 pair. 3 eliminates 3 here, so it's 5 and 3, which makes this 9. This 7 eliminates 7 here, so it's 6, which makes this 7, which makes this 6, which makes that 7. Therefore, that's left as a 6, which makes that 7. This 5 eliminates 5 here, so it's 7, which makes that a 5. Oh, that was such a bad assumption here. I don't know why I just completely ignored the 6 being possibly... Yeah, I don't know. That was just bad. Bad assumption, which made this way too much longer. Yeah. I had the logic all down. It's just... I just made a really bad assumption here with the 6s having to be the extra digit when it didn't. That was bad. Anyways, though, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.